In this presentation, we're going to talk about software processes and software development lifecycles. It's important to note the ones discussed in this particular lecture are idealized models. When you take on an internship or get that coveted first job, it's likely that the organization will have its own modified version of one of these life cycles. It's also important to understand that different models come in and out of favor as the industry changes and matures. Software process is a structured set of activities required to develop a working software system. These activities include specification, design, validation, and evolution. We use software process models to provide an abstract representation of the process. Here we have the three generic software process models. The waterfall models feature separate and distinct phases for specification development. Evolutionary development is where specification development and validation are interleaved. You can see this type of process model featured in Scrum and in BAME's spiral model. Component-based software engineering is where the system is assembled from existing components. You may see this type of process in bespoke implementations of systems such as SAP and PeopleSoft. In case you think I've forgotten about Agile, Agile is more of a categorization than a process. Plan-driven processes are processes where all of the process activities are planned in advance and progress is measured against this plan. In Agile processes, planning is incremental and it is easier to change the process to reflect changing customer requirements. In practice, most practical processes include elements of both plan-driven and Agile approaches. There are no right or wrong software processes. In the coming slides, we'll look at the three models and their variants. This is the way that software systems were initially developed. Users start by indicating what they want. The developer would then take the requirements and develop a system specification which would be given to the users to sign off. The developers would then create the system and deliver it to the users. Most people mistake the traditional method for the much maligned waterfall development method. But here you can see the arrows only go one way. The waterfall model was developed by Winston Royce in 1970 based on his experience with spacecraft mission planning and was an attempt to document a better way to deliver software. As noted on the previous slide, you can go back and forth between the operation and maintenance and other phases, so the arrows go two ways. Although Royce's model is much maligned today, it did represent a substantial improvement over the traditional model or having no process at all. The main characteristics of evolutionary or incremental development process model is that the phases of the software construction are interleaved with one another. There is feedback from the user throughout the entire process and the product gets refined through many different versions. There are two types of prototypes that get developed during the incremental development process. One are evolutionary prototypes where the prototype evolves to become the final product, and throwaway prototypes where the prototype is thrown out after the requirements are determined. The advantages to this model is that it provides an initial version of the system very early in the process and deals constantly with changes. The problem is that you can end up with a lot of quick fixes and there is not a lot of documentation. In terms of a process, we want to prioritize the user requirements and deliver the most critical pieces to the user first in incremental development. The earlier pieces of the system can act as a prototype. We can also use techniques such as extreme programming, Scrum, or other Agile methods. But the overall point is to deliver very small increments with team programming and the involvement of the user in the programming team. The spiral model is a risk-driven software development process model and was created by Barry Boehm in 1986. Notice that each phase includes a risk analysis and a prototype version of the system. Since there is a risk assessment performed during each iteration, the project team should focus on minimizing risk. We've used similar process models for past iterations of this class, although we might have made fewer trips through the spiral than are shown here. The main characteristics of the reuse or component-oriented model is that we make use of existing reusable components. The focus is on integrating the components rather than creating them from scratch. This can be good since it reduces the amount of software that needs to be developed in-house, but it can compromise the requirements in order to make them fit the software that is available. With the B model, the focus is on the operational aspects of the system. It's very similar to the waterfall, except that you can go back and forth and frequently repeat activities related to maintenance. Here, the focus of the model is rightfully on maintenance. The V model is synonymous with verification and validation. Notice that each deliverable on the right-hand side ties to an activity on the left-hand side. The B model and V model are just different ways of expressing the waterfall model. In the B model, we focus on the maintenance phase of the software development lifecycle, whereas in the V model, we focus on verification and validation. Let's take a brief look at the different stages involved in the software development lifecycle. Here we see the activities involved in the requirements engineering. The process begins with getting the requirements from the user, specifying them, and then validating. The end deliverable of this phase of the life cycle is the requirements document. The design process involves a lot more detail than the requirements phase. We start with the design inputs, including the requirements document. The focus is on design activities such as the interface, database, and architectural design. The outputs are the specifications for each of these products. There are three types of testing that are typically involved. There is testing of the individual components or unit tests, integration testing of the system as a whole, and finally acceptance testing, which lets us know if the product owner is satisfied with the entire system. Overall, there are two strategies for coping with change. One is change anticipation, the other is change tolerance. Change anticipation is where the software process activities include activities that can anticipate possible changes before significant rework is required. For example, a prototype system may be developed to show some key features of the system to customers. Change tolerance is where the process is designed so that changes can be accommodated at relatively low cost. This normally involves some form of incremental development. Proposed changes can be implemented in increments that have not yet been developed. If this is impossible, then only a single increment, a small part of the system, may have to be altered to accommodate the change. Thank you so much for watching, and be sure to check in on Laulima if you're not already there.